quiet, almost imperceptible ambient space sounds, perhaps a very low drone, begins and fades throughout as gentle background. Imagine, for a moment, standing on a vast, featureless plain. The air is still, cold, and utterly silent. Above you, there is no sky, no sun, no moon, and certainly no stars. Just an infinite, impenetrable blackness stretching in every direction. This isn't a scene from a dream, but a glimpse into the early universe, a period scientists call the cosmic dark ages. For hundreds of millions of years after the Big Bang, the universe was largely a featureless void, a vast expanse of hydrogen and helium without a single star to pierce the gloom. It was a universe waiting for light. Now, if I were to ask you where we might find the very first flickers of that light, the most ancient structures that brought the cosmic dark ages to an end, your mind would likely drift to the deepest, most distant corners of space, perhaps to galaxies so far away that their light has traveled for nearly 13.8 billion years to reach us. Remnants from the dawn of time, barely visible even to our most powerful telescopes. And you wouldn't be wrong to think that way. But what if I told you that some of the universe's oldest galaxies, these pioneering beacons, aren't in some impossibly remote cosmic wilderness? What if they are, in astronomical terms, practically right here, within what we might call walking distance of our own Milky Way galaxy? This is one of the most astonishing discoveries in modern astronomy, that the universe's earliest structures, the very first gatherings of stars that dispelled the primal darkness, are not just theoretical constructs glimpsed far across the cosmos. They are our neighbors, orbiting our own galaxy, quiet witnesses to cosmic history unfolding around them for billions of years. These ancient time capsules come in the form of incredibly faint dwarf galaxies, tiny collections of stars, so diffuse and unassuming that for a long time we didn't fully appreciate their profound age. Consider names like Segue 1, Bootes I, Tucana 2, and Ursa Major 1. These aren't the grand spirals or vibrant ellipticals we typically associate with galaxies. Instead, imagine wisps of starlight, barely clinging together, almost like cosmic ghosts. Yet, their modesty belies an astonishing truth. These particular satellite galaxies of the Milky Way are more than 13 billion years old. Just think about that for a moment. More than 13 billion years. Our Sun is only about 4.6 billion years old. The Earth, a mere 4.5 billion. These dwarf galaxies formed when the universe was only a few 100 million years old, a mere infant in its lifespan. They were among the very first galaxies to ignite, to gather enough matter to begin forming stars, finally pushing back against that overwhelming, ever-reaching darkness of the early cosmos. They are, quite literally, the first light that illuminated the universe, paving the way for the grander, more complex galaxies like our own that would eventually follow. Their very existence, their sheer antiquity, provides powerful evidence for the reigning cosmological model, the lambda cold dark matter model. It's a bit of a mouthful, but it's essentially our best framework for understanding how the universe evolved from its earliest moments to the intricate structures we see today. This model posits that an invisible, mysterious substance called dark matter plays a crucial, driving role in cosmic evolution. We don't know exactly what dark matter particles are, but we know they exert gravitational influence. And, according to the model, they began doing just that more than 13 billion years ago. In those earliest times, even before the first stars had fully formed, congregations of dark matter, by their immense gravitational pull, began to act like invisible cosmic shepherds. They slowly, patiently persuaded the particles of ordinary matter, hydrogen and helium gas, to accumulate. These dark matter clumps acted as gravitational anchors, drawing in the gas that would eventually condense, heat up, and ignite to form the very first stars. These stars, in turn, gathered into the earliest, smallest galaxies. The fact that we find these ancient dwarf galaxies so profoundly old and yet so close is a stunning validation of this picture. They are precisely what the lambda cold dark matter model predicts. Small, simple structures that formed first, anchored by the earliest clumps of dark matter. They weren't grand, bustling cities of stars, but rather the quiet, isolated hamlets that slowly, over billions of years, grew into the sprawling metropolises of the cosmos we observe today. So, the next time you look up at the night sky, and perhaps you manage to spot a faint smudge of light, remember that some of the most profound secrets of the universe aren't hidden at unimaginable distances. They are right there, among the familiar constellations, patiently orbiting our own galactic home. These humble dwarf galaxies, born in the deepest past, continue their silent cosmic ballet, carrying within their sparse stars the echoes of the universe's very first dawn, a testament to the enduring mystery and the slow, majestic unfolding of cosmic history. It's a humbling thought, isn't it? That some of the universe's most ancient wisdom, the story of its very first steps, can be found so close to home. What other ancient secrets do you think might be hiding in plain sight? Share your thoughts in the comments below. And if you found this journey into the cosmic past intriguing, please consider subscribing or following for more stories from the universe and beyond.